of the big party here, going pretty well. We will talk today about NMOS, how NMOS is ready, steady, and we will even have it a go with my colleagues. So when we say ready, we are ready to build, NMOS is ready to build into your IP-based media facility using open standards and specification. And steady, we will explain how the development of our specification follow a controlled evolution, and how we work to fill the gaps that are remaining. And go, because Richard will really show how we can use NMOS, how we can get started with real hands-on experience. So stay tuned for the demonstration. So I'll cover the ready part, and I will assume that everybody will have seen that once in their life. Is the EBU pyramid of media nodes. It gives a minimum user requirements to build and manage a large-scale IP-based facility, and that shows how 2110 needs a number of things around it to really build a big system. And you will see that at the center of the pyramid, NMOS, the network open media specification, API and set of specifications, are filling the middle part of the pyramid, especially layer 3 on operational control, where there's a need for discovery registration, connection management, device control, audio channel mapping. It's all covered or almost covered by NMOS. And a little bit also of the configuration part, where ISO 9 is there to provide common parameters for low-level configuration. So we'll go through what we have published so far in the NMOS space, just as a recap. But rather than going through the list one by one, I will show an example of how those APIs are operating together in an example of a system. So here we have a simple setup with a number of media nodes. So cameras that are sources and destinations like displays. We have even audio devices that can shuffle the audio and rearrange the audio, mix the audio together. So this is really our media ecosystem. And around it, we have a number of common services, and we have an NMOS registry. We have, or registries. We have an NMOS client, what we call an NMOS client, a broadcast controller, where the user can interact with panels. And we have also some NMOS system database and network controller in some cases. Everything is on the network. And first of all, it's good to know that how those communication between devices, how the controls that we will talk about can be secured, use BCP 00301. Using, for example, HTTPS communications. First step would be that once a device is boot up on the system and is reachable on the system, it will want to get some common parameters. PTP parameters are common across the system. Information about the NMOS registry are common parameters. So this is via ISO 9 that all the device can get this automatically. Then the device will register itself in the NMOS registry. So sender and receiver that are in those devices will register themselves, so that the controller can query that registry and be aware of everything that's currently online in the system. From there, it can establish connections. But before that, in some cases, the network is controlled by a network controller, the case of a software-defined network. And the first step before establishing a connection of a flow between a source and destination will be to establish a route in the network. So ISO 6 is there to talk to the network controller, or eventually other APIs that are proprietary to each of those network vendors. So once the route is established in the case of an SDN network, or in the case of an IGMP network where there's no network controller per se, the controller will establish at the demand of a user a connection between a source and a destination, between a sender and a receiver. So ISO 5 is there to tell the receiver to join a certain multicast address and to patch an SDP of the source, that of the sender, that contains a number of parameters like its format. So until this point, we have the equivalent of an SDI router. We can establish connections between sources and destinations. Now, in some cases, we need to also intervene in how the audio are mapped within the streams. So streams of audio can contain a number of audio channels. And sometimes you have to map the audio of the source to the destination. And ISO 8 is a way that the controller can tell when a device has an audio matrix embedded in his as a capability. It will be able to tell this audio matrix to map the proper channels, or to mute certain channels, or to swap certain channels, for example. BCP 00201 is a best common practice document that tells how to tag that different flows are related together and could be used as a bundle of flows. So for example, a camera has a video, as a few audio channels, flows maybe, and ancillary data. And all these three can be tagged so that the controller is aware that they go together. So in a system where there's a number of source and destination and a large number of senders of all types, it's good to know which belongs to each other. ISO 7 is for event and tally communication between panels and devices. So that gives the kind of very high-level recap of all what we have published today. Before going further, I'm pleased to announce a new content on the AMWA.tv website presenting NMOS at a glance, and it's really all the information you need to quickly understand the benefit of NMOS. There's a lot of links for free downloads, test tools, and all the information why you need NMOS and how to get started. So I'll pass the screen to my colleague Gareth for the steady part of the presentation.
Gareth, there we go.
Hi, everybody. Hi, everybody. So thank you, Wes, thank you, Felix. I'm Gareth. I'm a principal engineer in Sony's Europe Professional Engineering Division. My team is responsible for the NMOS implementation used in Sony's IP Live product range, which we also release as open source software and support on GitHub. Felix has talked about the technology pyramid and how NMOS fulfills many of the user requirements for operational control alongside other open IT standards and protocols. Those parts of the NMOS family are ready, mature specifications, as Felix has said. I'm going to talk a bit about the kind of steady, ongoing evolution of NMOS. So here's the pyramid again. One key area that the EBO identified that the industry really needs to develop is control plane security, highlighted on the slide there. The EBU Media Cybersecurity Group published some solid recommendations, and they list the AMWA BCP3 as the applicable open specification. BCP3 is actually a three-part specification. Each part leverages existing open IT standards and describes how we should be using them in our industry. There's the system diagram again, and BCP3 Part 1, secure communication, that Felix has covered, describes how to use current IT best practice for transport layer security. That's been a published AMWA specification since February 2019, last year. The current work in this area is to deliver BCP3 Part 2 and an interface specification, IS10, which together will enable secure authorization of clients for services in the system. And as an advert, if you're interested in finding out more about the security topic, come back to IP Oktoberfest again tomorrow for the presentation Underpinning the Pyramid. So all of the specifications that Felix has covered here and that we've identified really form a critical part of the open IP media facility stack. The governance of open specifications like this is obviously therefore important for the industry. So I'm going to give you just a brief overview of the AMWA approach to specification development and how it results in agile but steady controlled evolution for NMOS, like Felix has said. So at the end of last year, the AMWA board invited implementers and end users who are very active in the community to form a steering committee. NMOS steering works for the board and to set overall strategy and direction for NMOS. We have been meeting bi-weekly and have 18 organizations all actively participating, despite the challenges 2020 has brought all of us. The AMWA specifications are each developed by an AMWA activity group, which are initiated by the board. NMOS steering is responsible for overseeing the work of the NMOS activity groups. The AMWA process ensures that each new activity is focused on specific business value and are backed by sufficient actively participating end users and implementers to be able to deliver. NMOS steering doesn't do the work, it just helps to set them up to succeed in a timely manner, we hope. So as it says on the slide, we encourage activities to publish their work in progress openly to keep the industry informed, just like other IT standard setting bodies like the IETF. But the elevation to published specification always requires that the work meet a number of important criteria, demonstrating maturity. So besides business value, especially important is that interoperability between vendors can be demonstrated. The open source NMOS testing tool is a key part of this. It has test suites with good coverage of all the NMOS specifications we've been talking about, and has been a key component of the JTNM tested program, which many vendors have taken part in over the last 2 years. The testing tool is something that Sony have been really motivated to help the AMWA deliver and continue to maintain and extend. It's freely available for end users and for implementers to use. And Richard next is going to talk about one easy way of doing so in the next part of our presentation. The stable designation is only awarded by AMWA and currently only applies for NMOS to ISO 4, ISO 5 and ISO 8, when the specifications have a really good track record of interoperable implementation by multiple vendors shipping products. As we've seen from the EBU pyramid that we've looked at, the AMWA is only defining specifications where they offer new business value and suitable existing open standards and specifications are not yet available or need tailoring for our industry. For example, the security work leverages existing IT best practice, TLS, OAuth, and so on. Amongst the other things listed on this slide, NMOS steering reviews activity proposals for their fit with the NMOS architecture and that they have the active backing of the end user and vendor community. The rigorous AMWA process still allows us to respond quickly though. When editorial clarifications on the specifications are proposed, they can be reviewed and published as tertiary dot releases, such as version 1.3.1. These never make any functional changes to the specification, of course. And usually, these sorts of clarifications are, have been kind of demonstrated and accompanied by additional test cases in the testing tool. So we've introduced the published specifications, and so finally I'd like to give you just a glimpse of the activities that are currently going on. The security group, as we said, is kind of nearing completion of the authorization work, which we expect NMOS steering and the AMWA board to be able to review shortly. And as I said, it's all being developed openly, so everybody can review and comment upon the work that's being done by that group. 3 other groups are also currently active, all backed by proponents from both end users and implementers. The receiver capabilities activity is studying how NMOS devices should more precisely define the range of operating points that they can support using the existing RS4 specification and make the experience for controllers and users better. It's expected to deliver a proposed best current practice document for review before the end of the year. For the Pro AV space, we're quite excited to have a first activity running to show how the NMOS architecture fits with, in this case, EDID-based connection management. And it should also deliver a study document this year. The 4th activity that's currently going on is looking at higher level and device control. The first phase concluded with a review of existing open and proprietary technologies earlier in the summer, and the AMWA board is now considering a proposal for phase 2, leveraging existing open specifications to support reusable device control models. So we've shown you what's ready, how we're steadily evolving the NMOS family. So it must now, Richard, be time to go and get hands-on with NMOS. Over to you, Richard.
Okay, let's see if I can share my screen successfully. Even better. So, okay, hopefully
We're
I'm
looking
sharing.
good. Yep, we can.
We're looking good. We can see.
Yep.
Let me get that out the way, because that's probably not very helpful. So we'll put you in the top right-hand corner. So we've, Gareth and Felix have explained all of the different specifications, explained the roadmap, explained how these are stable and steady and available now. But one of the things that when you first look at this diagram, you think, oh, this is possibly a little bit too much to bite off and chew all in one big go. So what the developments have done is, what we've done as a set of vendors is to try and make NMOS easy to get into. So this is what's known as the Easy-NMOS development, and this is something that is now publicly available under open source and is freely available to the community. And if you look at this diagram, you can see that we've put some ticks on all of the different standards, and this is just to articulate and show what Easy-NMOS is actually going to empower you to do in a very, very simple way. So Easy-NMOS, just to give you a little bit of background, is, as I've already mentioned, it's open source, but it was actually predicated on something that Mellanox, which is now part of NVIDIA, did and presented back this time last year. Basically, we created a set of containers that we could run on Mellanox infrastructure, but since then, we've now made the technology open sourced, and we've now expanded that technology so that it supports multiple different architectures. So it supports ARM just as easily as it supports Intel or AMD processors, and is now significantly more available. You can pretty much run it on anything you want, and is completely covered by an Apache APL2 license. So it really is a case of take it, use it, take advantage of it. It's something for the community to use. Now, I highlight this is as a primer for this. It might be worthwhile going back to my presentation that I showed at IP Showcase back in 2019, where you can understand some of the motivations behind this on why we chose to do it. So we've put the links to that talk. It's available on the IP Showcase website, and the slides are also available from that. And the important thing is that everything in the Easy-NMOS solution set and tooling is completely open source. So the stuff and the technologies that we've done, the stuff and technologies that AMWA have done, and the stuff and technologies that Sony have done are all completely covered by an APL2 license. And we've even included at the bottom of this slide, all of the links. So if you want access to all of the source code and how it's built and all of the jigsaw pieces behind this simplification effort, then it's all readily available and public. So what have we done since IBC 2019? What have we done over the last year? Well, last year we just had something pretty basic. We had an NMOS registry that was available inside a container. And what we've now done is significantly enhance that. First and foremost, we now have not just a registry, but we have examples of the other two key jigsaw pieces that you would need in an NMOS environment. We have an sample NMOS controller that allows you to do ISO 4 and ISO 5 and other stuff and actually control things through a sample GUI. And we also have a virtual node. Now, this virtual node is obviously, just software. It's not moving streams around, but it actually operates as a valid NMOS node inside the system. So it's completely technically compliant to all of the standards. So it's a great way, it's a great reference for what you would need if you were trying to create an NMOS node in a system. And alongside that, if you look at all of the different AMWA specifications and capabilities, what we've also done is we've enhanced the containers so that we can cover much more of the specifications and across the board. So we've added in multi-architecture, so you can run these things on a Raspberry Pi, for example. We've added in ISO 8 support, and we've added in an MQTT broker, which is not part of the AMWA specification, but is something that's directly referred to by the ISO 7 NMOS standard. So basically the idea behind this is you now have all of the jigsaw pieces, or as much as possible, available for you to jump in to NMOS very, very quickly and very, very simply. ISO 8 from the NMOS controller, and also MQTT testing via the virtual node, and we are working on that now with other vendors such as Sony to close these gaps. So actually you will have a collection of tools that completely covers the AMWA specifications. Just to also add, we took these containers to JTNM tested in March 2020 at the beginning of this year. And we ran a version of these on our equipment, the NVIDIA Mellanox Ethernet switches, during that testing event. And the great news is that it passed all of the JTNM tested standards at the time. So we have all of those publicly available badges. So it's not something that we've just done in isolation. This has also been independently tested. So Easy-NMOS has been thoroughly tested within the community. Okay, and finally, it's supported by many different platforms. Obviously, most people are going to be running this on a standard host or inside a virtual machine. Both are supported. In fact, I'll be running it on a virtual machine today. And actually, the last line in this slide, it's already being extensively used. These containers are being used in production, believe it or not. And actually, there's been over 3,250 downloads of these containers to date. So they are pretty pervasive and well consumed by the community. So what is Easy-NMOS? So basically, we've taken these containers that we built or started building last year, and we've now combined them into a single solution. So what we've done is we've created a Docker Compose script and set of tools that allows you to install, configure, and run these containers basically as a 1, 2, 3 approach. And what that means is that any user out of the box can take this Docker Compose environment and basically have a fully compliant NMOS environment up and running literally in a matter of minutes. And that means that you can then start to test things, you can then start to look at the API calls, you can delve into the specifications in a much more quicker and easier way. And that's really the objective behind Easy-NMOS, empowering the user community and the developer community to jump into this with both feet. So step one. Okay, I'm just going to go through these steps at very, very high level, and then we're actually going to jump into a demo, and hopefully you're going to see all of this working. So really, step one is as simple as you've got to install Docker and Docker Compose, because that's what the infrastructure is built on. We do have a dependency on curl. So the first thing you need to do is to install curl. But what we've done is we've provided this install script that should do 95% of the heavy lifting. That will do all of the installation of Docker and Docker Compose and do all of the required configuration. And then if you want to, you don't have to do this, but if you want to, you can add your current user to the Docker group, which means that you don't have to do sudo on the Linux host to do most of the work. I would recommend you do that because it makes things a lot simpler for the operation of this going forward. So that's step one. You're basically installing the dependencies in Docker and Docker Compose. Step two is the one bit of the configuration we couldn't do for you. And basically this is because the Docker containers are configured in such a way that they operate literally as virtual hosts on your network. Unfortunately, we don't know the network that you want to run this on. So we need you as a user to give us 3 IP addresses that you need to configure in the file before you run this. And that really is about as much configuration as you have to do. You have to go and find these 3 unused IP addresses, configure them in the Docker Compose YAML file, and make sure you set the network correctly and the adapter, and that's it. Once you've done that piece of configuration so that you tailor our script for your network, you're pretty much ready to go. And then the third step is just run it. You use Docker Compose up, and then everything else out of the box is completely automated for you. So what's it actually going to do? Because we'll try and show you this in a minute. Basically, it creates all of the external network interfaces on your host and connects to your host, your physical host adapter. It then exposes the 3 IP addresses that you've given it to the external network so that if you have a LAN, you can access this and use it for testing purposes. It then goes and pulls all of the containers from the network. So it reaches out to the internet, and it goes and gets the latest versions of these containers automatically. It goes and gets the latest version of the AMWA NMOS testing suite and the latest version of the registry and the virtual node. It then starts them in sequenced order, because obviously there's no point having the virtual node running without a registry. So it starts the registry first, it then runs the virtual node, and then the final thing is it brings up all of the NMOS testing suite so that you can actually test things on the network. And then it creates or outputs an activity log directly to the screen. And the way this is used is it's color coded. So if you see the registry do something, or if you see the virtual node do something, or if you see the testing tool do something, each one of these has a different color associated with it. So you can immediately see the interaction between a node and a registry, or the testing tool testing a registry, etc. Okay.
Rich,
And yep.
I hope today's colors are yellow, orange, and green. I hope.
I didn't check, but we'll do our best. And basically that's it. At that point, you have a complete working NMOS solution running on your network. It really is as simple as this 1, 2, 3 approach. Okay, and if you need more information, it's all available on the AMWA website. The Easy-NMOS testing tool is pointed to the GitHub repository, and there's loads of information. And from there, you get access to all of the links and all of the open source content that's behind it as well. Okay, now one of the big advantages of this Easy-NMOS testing tool is that it actually allows you to delve into what is going on. So one of the things I'm going to show you after we've got everything up and running is how you can actually see the API calls running natively behind everything. And that's really advantageous, because one of the big things that you want to understand with NMOS is all of the different interactions between the registry, a node, and even potentially the testing tool. And all of this is visible and available through the tool. Okay, so now to the demonstration. So I'm hoping you are looking at a Linux prompt. So what you've got in front of you here is just my Linux virtual machine. I'm going to use this as the example, and it's pretty clean, but what I have done just to save a little bit of time today is I've already installed Docker and Docker Compose, but we will go through the install script anyway, because it's no harm in doing that. So you can see here that I've installed curl, which is a prerequisite. That was the thing that we did right at the beginning. And then I now need to clone the Easy-NMOS repository onto my system. Okay, so there we go. So basically I've downloaded all of the scripts and everything I need, and I can go into that directory, and you can see what has been basically pulled down. Okay, so the next step was to do the installation. Okay, so all I need to do is do sudo/install, and it will ask for my password. And because I've previously installed Docker and Docker Compose at this point, it's giving me this warning. Okay, if you hadn't installed Docker or Docker Compose, it would just go away and do this. But because I actually installed Docker and Docker Compose through this script, it's perfectly okay for me to rerun this process, and it won't cause me any problems. So what you can see here is it's actually identified. Let me scroll back so you can see what's going on. It's identified what host type I'm on. It's done all of the necessary updates. You can see it's installing Docker here. Okay, you can see it's doing a check and giving you the version, and then it's also doing the installing Docker Compose. So at this point, I can do Docker version, and I can see my version of Docker. And I can then do Docker Compose version, and I can see my version of Docker Compose. So pretty much everything I need to do. The second step is to edit the Docker Compose YAML file. And you can see here in pink, it's automatically highlighted the IP addresses of what I need to change. Okay, and this is the one step that a user would need to do. They need to use or configure the IP addresses for the network that you are running on. You need to set the subnet that you're running on, and you also need to specify your Ethernet adapter that's on your Linux host. Okay, those 3 different things are all of the configuration that you need to do. Now, because this is my lab system, it's already configured on all of this. I don't actually need to change anything, but it's something that you would just edit and then write the file. Okay, and then at this point, I can just start it. Now, because I'm doing an interactive demo this afternoon, okay, you're going to see this download the containers from the internet, start them, and then it's going to go wild. Okay, so full disclosure. And the reason it's going to go wild is you'll see the registry receiving all of my nodes in my lab environment connecting to it automatically. Okay, so I'm just going to show you a few things here before I run it so that you can actually see a little bit more of what's going on. So I won't start it just yet, but what I do want to do, is, let me see, wrong button. What I do want to do is to show you one of my reference NMOS receivers. Okay, I have several devices on the network, but this is a Fabrics QX. Okay, this is also passed the JTNM tested. But what you can see here is their NMOS panel. So this bottom left-hand quarter, you can see that it's not connected to any NMOS registry at this point. And that's because I don't have a registry running. Okay, so let me just go back and then hit go. Okay, so what it's doing is it's creating the network. It's now gone out onto the network, gone out onto the internet, and it's pulling the containers directly from a repository that's publicly available. And you can see that it's now downloading all of the jigsaw pieces into the Docker Compose or Docker subsystem. Okay, and once this is complete, it will then start everything in sequenced order. So you'll see the registry will start, then the virtual node will start, and then finally the testing tool will start. So we'll just give this a little second to finish the download. The testing suite is pretty big, and then it should go. So we're any second now, we should be off and running. Okay, so you can see now those 3 dones was when everything started up. And I know this is a wealth of information, but what you can see is all of the different things starting up. Okay, and you can now see on the left-hand side different colors associated with different containers. So NMOS testing is yellow, NMOS registry is blue, and the virtual node is green, and off it goes. Okay, you can now see inside the registry, so let's see if we can pick one here. Scrolling up, you can see that we have 6 nodes. Oops, missed it. We have 6 nodes there. Missed it again, but basically everything is registered and it's up and running. Okay, so let's have a look at what you've got. So let's go to this tab, and I should now just be able to type NMOS registry.local. And there we go. Okay, so now you're actually talking directly to an NMOS registry, and you have all of the NMOS APIs under this URL. One of the nice things here is we've also have the controller built in. So if we click on admin here, okay, we now get access to an NMOS controller. It's just a reference controller. There is others available, but this is just a nice way to do it. And actually now I can see my devices, my nodes, my devices, my senders and receivers. So you can see that's a load of things have registered. We have some real stuff and we have some Easy-NMOS stuff. So just so you know what we have here, we have a Fabrics QX, which is acting as my reference receiver, and we're going to do some live flow switching in a minute. We have an Embryonics module that's providing a reference sender. Okay, we have an Easy-NMOS node, which is our virtual node that's automatically connected. We have NVIDIA RiverMax, which is our NIC implementation that's providing SMPTE 2110, and that's also acting as an NMOS sender. We have a Sony virtual node that just so happens to be running on a Raspberry Pi that I have plugged into the lab. And we also have the registry. So basically we've got Fabrics, Sony, NVIDIA, and Embryonics acting as real devices. And we have the Easy-NMOS node, which is the virtual node that's being provided by the container. Okay, so let's have a quick look at some of this working. So let's go back to my Fabrics, because this is my reference receiver. And you can see that it's not receiving anything at this point. So let's go and have a little look at the Fabrics. So let's go to receivers. Okay, and you can see here I have my Fabrics devices. I have channels available. So I have video, 2 audio, and an ancillary channel. So let's take a peek at the video one and look at active. And you can see that nothing is active at this point. The master enable is disabled, which means it's not receiving anything. So let's connect it to something. Let's give it a go. So let's connect it to that one. So we'll connect it to one leg on a SMPTE 2022-7 system, and you can see that it's automatically been updated. And if I now go back to my Fabrics, you can see now that a couple of things. Firstly, you can see the Fabrics is connected to my registry. You can see its IP address is here. Secondly, now that I've done the connection, you can see the SDP file, or the manifest file as it's known as, under the NMOS specifications, has been sent to the Fabrics. You can see that it's been told to connect to a video stream or a 2110-20 stream. You can see that stream in the top right-hand corner. I apologize, this is a little bit blocky today because I'm using a VNC viewer so that I can show this over Zoom. But trust me, if I was in front of the device, it would look perfectly okay. And you can see in this panel here that it's actually identified or actually been told by NMOS what the parameters of that flow are. So you can see that this is all of this information down here has been interpreted so that it's now configured itself so that it's dealing with a 1080i, let's have a look, 1080i 50 flow. And that's about right. We're receiving about 1 gigabits worth of data on the Fabrics. So let's do a flow. Let's do a switch. So if I now go to connect, let's pick on another one. Let's go for the NVIDIA RiverMax solution. This one's pretty simple. And we click on activate. Okay, and you can see now that the sender that this receiver is connected to has changed. It's been updated. Okay, and if we now go to this, you can now see that you're now looking at the RiverMax test pattern. That's just a default. You can see that we've received another set of parameters. You can see that we're now connected to a different flow. You can see we're now connected to still a 2110-20 stream, but it's twice the bandwidth. And the reason it's twice the bandwidth is because we're now looking at a 1080p stream, 1080p 50 rather than a 1080i stream. Okay, and we can just keep doing this. So let's connect to another one. So let's go for this one. Connect to leg 1, and you can see it's updated again. And you can see that we're now looking at another reference source. This just happens to be, I think it's Sky News or something that I'm just using in the lab. And let's look at something different. So let's go for something different. So let's go to receivers, and let's do an audio. So we'll click on audio, and again, you can see that at the moment, audio is not connected to the Fabrics, but let's connect that. So let me just filter this for one that I know is operational. You can see it's active, and I can activate that. Okay, and again, it's updated, and away we go. So let's go and see what the Fabrics is showing. And you can see now on the audio bars over here on the right-hand side, you can see that we're now receiving audio. And you can now see in this panel that we now have the video and the audio being received by the Fabrics. You can see the data rates. And interestingly, you can also see the protocol. And even up here, you can see the audio packet time and number of channels that have been interpreted by the Fabrics. Okay, so let's have a look at some of the tooling. So let's delve into this a little bit more. So let's go for video. Where are we? There we go. And we're going to do a connection change here. So let me move this out the way. So this time I'm going to use my browser and I'm going to go to more tools. And in here, you have a great button called Developer Tools. And this opens a developer panel. And what it now is going to do is it's going to show you everything that is going on, all of the API calls and everything that is going on underneath. So let's do a flow swap. So let me just have a quick look. What are we connected to? We're looking at Sky News. Okay, so let's put it back to the RiverMax test pattern, which is this one. So if I click on Activate here, you can see the API calls as they whip past, and I'm not going to go and explain all of these tonight, but what you can actually see is, let's firstly prove this. You can see that it's switched, okay? But let's go into some guts. You can see here now, here are all of the parameters that were passed to the Fabrics. This is just an example of one of the NMOS API calls. And you can go in and see exactly what is going on in every single step here. And that's one of the beauties of this implementation. Not only is it easy to get into, but it's really, really easy to see what's going on inside NMOS. And finally, just for interest, let's have a look at the MQTT broker, because that's also built into the NMOS registry container. This will take a couple of seconds to kick in, but basically MQTT is one of the different communication methods that can be used under ISO 7. So we built it in. It's something that we could add in. And in here with MQTT, you have two concepts. You subscribe to the message broker, and then you publish to that message broker. And if you publish something, everybody that is subscribed to that topic will receive the message. Okay, so let's just do an example here. So I'm going to subscribe to a topic called NMOS. Okay, and you can see here that I am now have my valid subscription. And then again, I'm going to publish to the NMOS topic. And this is a cool NMOS message. Okay, and you can see here that actually I received something down here, because what you've seen me do is I click the publish button. The message was sent to this topic. And because I was subscribed to that topic, you see that I received that message back from the broker. And if I change the topic that I'm now publishing to, okay, and then click publish, it has been sent. If I click this publish button, it has been sent and has been sent to the message broker, but I'm not receiving that message myself because I never subscribed to that topic. So what I'm trying to show here is, in summary, NMOS is really easy to get into. It's something you can install in literally a few minutes. It's something that you can jump into with both feet now. You have all of these free tools that are available to take advantage. And actually, sorry, I forgot to do one more thing. Let me just show you the testing tool, because that's rude not to do. So you can see here I've just connected to the testing tool, which is one of the containers. Let me click on that and we'll just run a registry test. There's lots of tests built into this. It's a very powerful suite, but let's just start a registry test off. Okay, so let's run that. Okay, so you can see that I now have this running. So let's go and see what's going on in the registry. So if I go to nodes, you can see here, or the testing suite is adding loads of nodes into my registry. You can see all of this going on. So it's actively testing all of the APIs to make sure that they're completely compliant. And it's doing that by creating these mock nodes and testing every single API in sequence. And if I go back to this, you can see all of these things going on. So you can see here the registry is receiving all of these series of tests from the NMOS testing suite, and it's now having to comply to those tests, and it'll either pass or fail them, basically. And eventually what you'll see here is hopefully a yellow badge appear, which is the NMOS testing suite returning its results to the screen, and then we can take a peek at it. So this might take, there we go. So you can see there under NMOS testing that it's completed the testing and it's responded accordingly. So let's just go back.
Hey, Richard, can we wrap up and continue this in the breakout room for you guys?
Yeah, I'm going to be 2 more minutes, Wes, and then I'm done. Okay, so you can see here we have the NMOS testing suite publish the results, and you can see that it's passed all the tests. Okay, so in summary, you have the containers, you have the registry, you have a virtual node that can be used as an example. You have the testing suite that allows you to test nodes and registries. Everything is open source. Everything can be installed literally in a matter of minutes. You've just seen me do it, literally live. And importantly, it works with real devices. So you can do real flow switching. You can test your own equipment and test all of your functionality in your environment. Thank you very much for the patience. Thank you for watching the demo. I apologize that took a little bit longer than I anticipated, but